In this problem, we are looking at the difference between instantaneous and average rates of change. Another way to think about rates of change when we're looking at a graph is about slope. It's the slope. But what's the difference between instantaneous and average? Well, instantaneous rate of change is the slope at that point. How fast is the function changing at some particular point? But an average rate of change would be an average rate of change over some interval. So for example, on this graph that we've got here, if I looked at this point right here, 2, and I wanted to get its slope, well, it looks like it'd be a negative slope, right? It's going down there, probably close to -1. If I looked at this point right here, whatever that is, 2.3 or 2.4, looks like the slope is pretty sharply positive, maybe a +2. So those are both instantaneous rates of change. But if I wanted the average rate of change over this interval, well, it starts at a height of 2 and it goes to a height of 2. That's actually an instantaneous rate of change, or a slope over that interval of 0. It doesn't actually change at all between those 2 points, as far as we can tell just by looking at those 2 endpoints. So that's the difference between instantaneous and average rate of change. And we're going to be using that idea in this problem. It's a fairly lengthy one with a lot to write down. We'll take this a piece at a time. And they do, and ALEKS give you this to play around with. You can mark this up and erase things and draw lines and all kinds of stuff on it. We'll do some of that. They do give you a note here about estimation. It says you're asked to make some estimates, and ALEKS will accept a variety of answers within a tolerance level, but to get within that tolerance interval, you might have to type in a decimal. So don't be thinking you have to just type in integers. Okay, let's look at the first part. It says consider the interval of x values from a to 3. So from some number up to 3. Okay, so 3 brings us to right there. Okay, so from some number up to 3, find the value of that number, find the value of a, such that over the interval, the average rate of change with respect to x is -1/3. So we want some point on this function to the left of this one, where across that interval, it's going to go, well, down 1/3, a slope of negative, or a rate of change of -1/3. It's rise over run always. So -1/3 means down 1 and over 3. And I can just see, if I go over 3 this way and then up there, then this line would have a slope of -1/3 because it goes down 1 and over 3. So the number here, we need to start this interval at 0. So my number for A is 0. That interval 0 to 3 gives us that slope of -1/3, the average rate of change. All right. Then estimate a value of x in that interval at which the instantaneous rate of change is also -1/3. So let's look at that. Where do we see in here someplace that's kind of a shallow negative slope? -1/3 is going to be like that, or maybe even shallower. And it's definitely not here because that's very steeply down. It's definitely not here because that's positive. The place where I see it getting really shallow but still negative is right in there. So I'm going to say that's maybe I don't know, 1.8, and this is where the decimal comes in. So 1.8. If you said 1.7 or 1.9, it would probably accept it too. Okay, so that's the first part. Second part, consider the interval of x values b to 6. Find a value of b such that over the interval, the average rate of change of y with respect to x is -3/2. So we're ending at 6, which is right here. We want to start somewhere. We don't know where, but so that the rate of change is -3/2. So -3/2 means down 3 and over 2. So if I go over 2 the other way and then up 3, looks like I put myself right there. And that would be a slope of -3/2. This line that we'd sketch right there would have a slope of -3/2. So I think we have to start then at 4 for that interval. Okay. So our number b is 4. And then it says we want to find a spot on that interval where the slope actually is that negative 3/2, where the instantaneous rate of change is negative 3/2. And for most of this, we're either at 0 here, it looks pretty flat on the top, or we're very steeply down, more steep than this line. I think it's got to be like right off the edge here that we'd get one that's similar. So to me, that looks like 5.1 maybe. So I'm going to put that in there. Okay. Now it says consider the interval of x values from 6 to c. So for starting at 6 and going to some other number over the average rate of change, find a value of c so that the average rate of change is 1. So starting here, here's 6. We want a slope of 1, which you can think of as 1 over 1. Whoops, 1 over 1. So up 1 over 1. So I'm just going to keep doing that. Up 1 over 1, up 1 over 1, up 1 over 1. Aha, and I ended up there. So if we chose this interval from 6 to 9, that function would have an average rate of change of 1. So we'll put that in there. There's 9. And then estimate a value of x in that interval at which the instantaneous rate of change of y with respect to x is also 1. And this is where they might catch you. It gets a little tricky here. There's a sharp point here. It looks like a lack of continuity in this graph here. It's sharply sloping down all throughout here, and then instantaneously it seems to sharply slope up. So I don't see a spot where there's actually a slope of 1. What that means is that this does not exist, and that's one of your choices. So does not exist. And you can see something, you can learn something from this idea. There were places where the slope was equal to the average slope in this interval and in this interval, but not in this interval. What's different about those intervals? In the first two, the functions are continuous. They are smooth. They don't have sharp corners. They don't break off. If you've got a continuous function, there's going to be a slope that equals the average rate of change at some point, but not necessarily if there's a discontinuity like that. All right. Well, so that was a little bit of work with instantaneous and average rates of change.